Okay, this is going to be a quick video, so make sure you pay attention. I'm just going to go over bits and pieces of the chapter. All right, this is chapter 6.2. Basically, this is talking about equal treatment for all. It is important for you to treat everyone equally in an experiment because you don't want someone to get the idea that they feel more comfortable. So you want to make sure everyone's on a equal playing field. For instance, if you notice in this particular case right here, in this one, mice or rats were given a new product, and then some rats were given a standard product. Well, they already knew that there was two cages up top and cages on the bottom. Well, the cages up top, they know that the rats they grow faster if they live in the upper cages. Well, if you combine that with the new diet, then that's like a double whammy. What's happening is if you assign rats who are getting the new diet to the upper cages, then that's leading in bias because you don't know whether it's the fact that they're in the upper cage that's increasing their growth rate or if it's the new diet. So what the solution is for this, and what they've suggested is, the solution is to assign the rats to cages at random. Okay? So in that way, you have a variety of rats in both the upper and lower case. Also, down here in the bottom, they tested these rabbits. They randomly selected certain rabbits to receive affection, and what they found that those rabbits who received the affection actually had a lower cholesterol. So maybe affection does create a bias in which the rabbit's cholesterol level is a response variable. So be careful whenever you're creating an experiment that you give equal treatment to everybody. All right, double-blind experiment is when neither the subject nor the person giving the treatment knows what the subject is receiving. So no one knows except for the person who owns the experiment. So neither the subject nor the people who work with them know which treatment each subject is receiving. Also, make sure that there's equal treatment for all subjects to be sure that the placebo effect operates on all subjects. So basically, if you're giving one group a placebo, you want to make sure that they're getting just as good a treatment as those given the clinical trial, because you want to make sure that they don't get left out and they don't feel any different. So if they recognize that they're being treated differently, they're going to react differently. The powerful placebo, in this case, what they found is that 42% of balding men maintained or increased the amount of hair on their heads. What happens? They gave them a placebo, said, "Hey, this is going to help your hair," and sure enough, 42% of the balding men maintained or increased hair growth. Also, in this little experiment, there was another little experiment where they zapped these people. They zapped them on the wrist and then gave them a cream and said, "Hey, this is going to make it feel better." Well, then they zapped them again, and 8 of those subjects said they experienced less pain. So that's the power of a placebo. You know, placebos work, and it is a good place to start when you start thinking about planning medical experiments. Now, let's talk about minorities in clinical trials. A lot of times, because there's a lot of studies that show that minorities and women and elderly and poor have long been underrepresented. Sometimes these people decide not to participate, or they refuse to participate because there's maybe a lack of trust or in the medical establishment. So one of the things that we can do is, some remedies for lack of trust are complete. It starts right here, okay? Are complete and clear information about the experiment. So if you're upfront and honest about the experiment, then these minorities or women or the poor and elderly might be more willing to participate. Also, be upfront with their insurance coverage. Tell them that it's covered for their experimental treatments. That way people are not as concerned with these medical treatments or these experiments, and they'll be more willing to participate. Let's see. All right, non-adherers. This little word right here, non-adherers. When people don't follow through with the experiment that they signed up for, that can cause bias because AIDS patients, like for instance, AIDS patients who participate in trials of a new drug sometimes take other treatments on their own, for example. What's more, some AIDS subjects have their medication tested privately. and drop out or add other medications if they were not assigned to the new drug. So this may bias the trial against the new drug. So be careful. Those are called non-adherers. Then you have something called dropouts. Well, let's say if it's over a long extended period of time, well, if they don't complete the experiment, these people they drop out because due to the let's see, where it says, or say they're dropping out because of things unrelated to the experiment. Well, that's okay because they just reduce the numbers of the subject. But if they're dropping out because they have a reaction to one of the treatments, that can cause bias, and that needs to be documented. All right, now make sure that whenever you conduct an experiment, that it seems realistic. If you have a subject, let's say a student who knows they're in a subject and it's a rigged game and that it's in a psychology lab, well, that's unrealistic if you're trying to discover the frustration on teamwork in a workplace. So it's not in a real setting. So make sure you try your best to make it as real as possible. Center brake lights. When center brake lights came out before 1986, there was a reduction of almost 50% in rear-end collisions. But as time moved on, a decade later, that reduction was only 5% in rear-end collisions. So basically, what happened was it no longer captured people's attention. They became used to that third brake light. So the environment changed. So you got to be aware of things like that change over time. Now, subjects are treated too well. If you read this down at the bottom, it is likely that a therapy that beats a placebo in a clinical trial will beat it in ordinary medical care. But cure rates or other measures of success from the trial may be optimistic. Okay, may be optimistic. So be sure you read that. Now, finally, a couple more things. When we talk about this is talking about your ABC project, when they took the kids in North Carolina and put half of them in a daycare and the other half not in a daycare. When experiments are not fully realistic, that's this part right here in blue. Statistical analysis of the experimental data cannot tell us how far the results will generalize. In other words, if you're trying to project in the future that this would last, like the brake lights, I mean, they didn't know that after 10 years that people weren't going to recognize the brake lights, so it went from 50% to 5%, just like here. Some experiments we can't generalize how far in advance these things will work. For instance, in this one, we don't know what kind of a daycare or what's going to be the best daycare for these people, or what level of daycare is going to be the best. So this question right here, how good must daycare be to really help children succeed in life? Good experiments down here at the very bottom. Good experiments combine statistical principles with understanding of a specific field of study. All right, experimental design in the real world. Now, here's your steps, okay? Make sure you see this. All right, first of all, divide the subjects at random into as many groups as there are treatments, then apply each treatment to one of the groups, okay? Now, this is called a completely randomized design. Make sure that the experimental design, all the experimental subjects are allocated at random among all the treatments. So let's look at a couple of things. All right, for instance here, let me erase this. We have hot, warm, and cold water. So here's your variables on the temperature, and here's your variables for cleansing agent. Well, when we multiply this together, we get 9 treatments. So whenever you make this combination, or whenever you experiment this, make sure there's going to be enough people to go in 9 treatments, or enough subjects to go in 9 treatments. This kind of combination effect is called an interaction between cleansing agent and water temperature. Interactions can be important, as when a drug that ordinarily has no unpleasant side effects interacts with alcohol to knock out the patient who drinks a beer. Because an experiment can combine levels of several explanatory variables, interactions between the variables can be observed. So you're going to look at you're going to have 9 observations right there. Now, matched pairs basically combines matching. So this right here combines matching with randomization. So matching with randomization is the matched pairs design. A matched pairs design compares just 2 treatments. So you're going to choose pairs of subjects that are closely matched as possible, and then you're going to randomly assign the 2 treatments to the subjects in each pair by tossing a coin or some other fashion. But you're basically going to randomize the treatment. And then sometimes each pair in the design consists of just one subject. So like, for instance, if you're going to see how a person does taking a test with a lot of noise and say a test in a quiet room, or let's say the test with rock music versus classical music, well then that person is a matched pair because you're matching him or her against themselves. So, but you're going to randomize the order for each subject. So you're going to randomize the order of the treatment. Okay, so you're not just going to do like rock music and classical, rock music and classical. You're going to randomly assign those. And then here's a block design. Basically, here's your block design. It's a group of experimental subjects that are known before the experiment to be similar in some way. So we're going to block things. So here it goes. What you're going to do is we're going to block the men and women. So blocking women and men. And then from there, we're going to separate them into 3 groups because I have 3 separate treatments. Okay? 3 separate treatments. Oh, another thing back here is blocks are another form of control. So whenever you block a group, you're actually trying to eliminate bias. And then finally, here are some key elements and key words that I've highlighted that we've gone over in this chapter 6.2. Just make sure you read these. We've talked about block design, match pair design, random design, completely randomized design, generalization, non-adherers, dropouts. So these are some of the vocabulary words you need to be aware of.